We discussed in the first two works continuity at a point. In the third part, we will discuss continuity at interval. A function is said to be continuous in a closed interval a to b if it satisfies three conditions. First of all, a function is continuous inside the interval, which means it's defined over all the intervals inside, not at A, not at B, it's between A and B. Second thing is limit when x goes to A from right should equal to f at A, because when we have here A, here we have B, our function is defined only inside the interval. So here is we have right of A, so that's why we say limit when x goes to A from right should equal to f at A. Similarly, B has only left neighbor, that's why we say the third condition, which is the value of the function at B should equal to limit when x goes to B from left. Going to the questions, here it says find a value of C and D that makes the function continuous. So here what we have minus 3, we have plus 3, we have in between 9 minus x squared over 4 minus root x squared plus 7. The reason when we say absolute value of x less than 3, this is equivalent to say x is between minus 3 to 3. At minus 3, the value is D. At 3, the value of, at 3, it's D. At minus 3, it is C. So our condition will say f of x first is continuous inside the interval minus 3 to 3. The reason because it will not be continuous when the denominator is 0. When the denominator is 0, it's not inside the interval. If we say denominator is 0, then we have 4 equal to square root of x squared plus 7. That would mean when you square both sides, you get 16 equal to x squared plus 7, which means x squared would be 9, which means x equal to plus or minus 3. But these both points are not inside the interval minus 3 to 3. That's why we said it is continuous inside the interval. That's the first condition. The second condition, we need to satisfy the value of the function at minus 3 must equal to the limit when x goes to minus 3 from right. And that will mean what? F at minus 3 means it is equal to C. C should be equal to limit when x goes to minus 3 from right. Our function is 9 minus x squared divided by 4 root x squared plus 7. So when we multiply it by the conjugate, 4 plus root x squared plus 7. Here we will say 4 plus root x squared plus 7. Now, when we multiply by the conjugate, what we will get? Limit when x goes to minus 3 from right. Here we have 9 minus x squared times 4 plus root x squared plus 7. Here we have 16 minus now. Here we have to be careful. We must have bracket x squared plus 7. So that will be equal to limit when x goes to minus 3 from right, 9 minus x squared, 4 plus root x squared plus 7. And here I will have 16 minus x squared minus 7, so it will be 9 minus x squared. So these will be cancelled, and you will get c is equal to 8. Similarly, the third condition, f at 3 must equal to limit when x goes to 3 from left. But that means f at 3 is equal to d. And the limit when x goes to 3 from left, we have the same function, 9 minus x squared divided by 4 minus root x squared plus 7. If we multiply by the conjugate, 4 plus root x squared plus 7, and here by 4 plus root x squared plus 7, doing the same calculation, we will get also it is equal to 8, because when I multiply by the same conjugate, same cancellation, and same answer will be as a consequence. Now, here is another question. It says we have minus 1 to 1. If it is at minus 1, you need to put it in cx plus d. If it is at 1, it's dx plus 2. If it is in between, you have x squared minus 1 divided by square root of x squared plus 3 minus 2. Similarly, we have to do the same story. We should say f of x, that's the first condition, is continuous inside the interval minus 1 to 1. The reason, because our denominator, when it is equal to 0, x squared plus 3 minus 2, if it is equal to 0, that will mean x squared plus 3 equals to 2, which means x squared plus 3 equals to 4, which means x squared is 1, which means x is plus or minus 1, but that is not in the interval minus 1 to 1. The second condition, we need to satisfy f at minus 1, when f at minus 1 must equal to limit when x goes to minus 1 from right. And that will mean when I substitute minus 1, I put it here. So I will get minus c plus d must equal to the limit when x goes to minus 1 from right. My function is x squared minus 1 root x squared plus 3 minus 2. I need to multiply it by the conjugate, root x squared plus 3 plus 2. And that is root x squared plus 3 plus 2. Now that will be equal to limit when x goes to minus 1 from right. This is x squared minus 1 square root of x squared plus 3 plus 2. And that will be x squared plus 3 minus 4. And what's that one? X squared plus 3 minus 4, it's minus 1. So that will cancel out, and you will get this is equal to 4. So we concluded minus c plus d must equal to 4. That's the first equation. Call it equation 1. Number 3, the value of the function at 1 must equal to the limit when x goes to 1 from left, because here 1 has a left neighbor. So our function will be, when we substitute 1, we substitute it here, so we will get d plus 2 is equal to limit when x goes to 1 from left. When we say 1 from left, it will be the same thing here. It will be x squared minus 1 over x squared plus 3 minus 2. If we multiply it by the conjugate, x squared plus 3 plus 2. And here x squared plus 3 plus 2, we will get the same thing. It will be 4. So this will mean I get another equation, d plus 2 equals to 4. From this one, I will get d equals to 2. Replacing d by 2 in equation 1, we will get minus c plus d, which is 2, equal to 4, will mean minus c equal to 2, which means c equal to minus 2. So these are the two values which makes the function continuous. Now here it says discuss the continuity. That's our last question. Discussing the continuity. Here we have, this is minus infinity, that's plus infinity. We have 1, we have 2, and we have 3, and we have 5. Our question, it says between 1 and 2, you have x plus 2. Between 2 and 3, you have 2x minus 1. Between 3 and 5, it's x plus 3. Nothing here, nothing there. We should not bother ourselves. So we will say the first condition I need to satisfy, I should say f at 1, is it defined? F at 1 is not defined, undefined. Okay, limit when x goes to 1 from left, 1 from left, it's x plus 2, so it will be 3. Limit when x goes to 1 from right, so limit when x goes to 1 from, sorry, we should say only 1 from right. We don't have from left, sorry. So what we will say now, at 1, our function is not continuous. So our function at 1, so we say here, sorry for this disappearing. So if at 1 is not defined, limit when x goes to 1 from right of the function, we said its limit when x goes to 1 from right, it's x plus 2, which is a 3. So we will say here, f of x is discontinuous at x equal to 1 because we have both. If 1 is not defined on the right limit, of course, if we have no value, it will not be equal. To discuss it at 2, we need to have f of x. What is f at 2 first? F at 2, when we say f at 2, it will be 2 plus 2, which is 4. We need limit when x goes to 2 from left. Because at 2, I have left and I have right. From left, it will be x plus 2, which is again, it's 4. Until now, it's fine. But what is limit when x goes to 2 from right? It will be limit when x goes to 2 from right. 2 from right, it will be 2x minus 1. So it will be 4 minus 1, which is 3. Unfortunately, they are not all equal. So we will say f of x also is discontinuous at x equal to 2. Now we have to go to 3 and do the same thing. At 3, what is f at 3? F at 3, it says here, if it is equal to 3, you need to substitute here. So it will be 3 plus 3, which is 6. Now, what's the limit when x goes to 3 from left? Limit when x goes to 3 from left, it will be 2x minus 1. So that will be 6 minus 1, which is 5. And limit when x goes to 3 from right will be limit when x goes to 3 from right. This is right of 3, so it will be x plus 3. So I'll get here 6. Can we say continuous? They are not all equal, so we will say again f of x is discontinuous at x equal to 3. The last point now we need at 5. What is f at 5? F at 5 is undefined. And limit when x goes to 5, we have to worry only about left of the function f of x. So it will be limit when x goes to 5 from left, which is x plus 3, so it will be 8. So that will finish. We discussed continuity at 1, where we have to have limit from right equals to the value, but the value is not defined, so we say not continuous. At 2, we have limit from left equals to 4. Value is 4, but limit from right not 4, so we'll say not continuous. Same thing at 3. F at 3 is 6, limit from right is 6, but limit from left is 5, so it's not continuous. At 3 and at 5, to make it continuous, we have to have limit from left should equal to the value of the function at 5, but unfortunately, f at 5 is not defined. That's our discussion of continuity. This will end up all sort of questions which we have about continuity. Thank you for listening.